So let's get started. I'm going to talk a bit about iSCSI. First of all, I can imagine that there are people in the audience who don't really know what iSCSI is, how it compares to other storage. So I'll share a little bit about what iSCSI is, and then I will share with you our current thinking of what an iSCSI implementation of OpenVMS would look like. This is still something that is very much in development, and the details may look a little different when it actually comes out, but it reflects our current state of thinking about this. As with everything we do, the reason we're getting into iSCSI is to help our customers protect and realize the full value of their application investments. We see many customers that have VMS clusters that want to go to virtual machines, that want to go to the cloud, and they want shared storage. And they don't want to rely on MSCP and have like a single point of failure in accessing that storage. And of course, on a virtual machine, there are some limitations. If you're running with fiber channel pass-through, you're tied to a specific box. You have to like lock all your memory and things like that. And in the cloud, going with fiber channel pass-through is a no-go. So we believe that going to iSCSI will really help our customers here. So what is iSCSI? iSCSI is a storage protocol, and it is block storage over TCP/IP. It's not like something like NFS or Samba, which is file storage. This is block storage, and it doesn't come with a file system. VMS will put its own file system on a fiber channel or on an iSCSI volume. So it's more similar to fiber channel in that regard. There are different ways to provide iSCSI storage. You have your traditional storage arrays like an MSA 2060 with iSCSI controllers in it. But you can also offer iSCSI storage from an appliance, a virtual machine, something in the cloud, a physical server running an operating system like Linux or FreeBSD. You can configure pretty much any piece of hardware as an iSCSI server. And in many places, iSCSI is gradually replacing fiber channel. Not everywhere, but in a lot of places it is. If you walk into an Oracle Cloud data center, you will find that all the storage is based on a combination of iSCSI and remote DMA. There's no fiber channel storage in these cloud facilities. Some terminology to start off with. iSCSI starts with what they call an initiator. And an iSCSI initiator is a consumer of iSCSI storage. It's the client side of the connection. And an iSCSI initiator can either be software. You have software initiators, just a simple program that talks over TCP/IP to an iSCSI storage device, or it can be a network card with built-in hardware capabilities to do iSCSI protocol. Then an iSCSI server, that's more or less self-explanatory. It's a piece of hardware that offers iSCSI storage, and it does that by offering what are called targets. So you have one server can offer multiple targets. And a target has a name. It's called an IQN. And a target may consist of one or more LUTs. So as an iSCSI initiator, you do not connect to the server. you connect to a target on a server. And by connecting to that target, you receive one or more LUNs that you can use. So if I'm going to connect to a target, I need 3 pieces of data as a minimum. I need to know the IP address of the server that is offering the storage. I need to know the port that it's using for the iSCSI protocol. Normally that is 3260, but it can be different. And I need to know the iSCSI qualified name for the target on that server. And an IQN always has this format. It starts with IQN dots, then a date in the form of year-month, and then some company name followed by a colon and then a user-definable target name. And hopefully, when I get into what it will look like on OpenVMS, some of this will become a little clearer. Any questions so far about what iSCSI is? Well,
I begin offhand, I assume it's organized when you not associated with server IP.
No, it's not.
Controller.
This IQN is, that name can be reused in multiple places. It's the combination of IP address and IQN that needs to be unique. I would advise you not to use it for different controllers, but in theory you could.
Well, what about something like the MSAs?
Yes, exactly.
Both IP addresses.
If you have
the same target IQN for the same volume, you get useful quotient like the UIDs on fiber channels. The same UID, same IQN has to be unique to that data item.
We'll get to that.
Okay.
So, iSCSI on OpenVMS. Again, this is our current thinking of what this will look like. So, iSCSI device names. When we are in a cluster and we connect to a storage device, an iSCSI target in this case, we get some LUNs, and we want the device names assigned to those LUNs to be deterministic. If I connect to the same storage from 2 cluster nodes and I get a different device name on those 2 nodes, it's bad because VMS will believe that those are 2 different volumes and the log manager will not protect my data on that volume. With Fiber Channel, the way we supported this was by requiring the assignment of a unique user-defined identifier to each LUN. And then the UDID becomes the unit number part of the device name. So if you set the UDID to 100, the LUN you get on VMS shows up as $1 $GGA 100. Unfortunately, UDIDs were part of the Fiber Channel or SCSI specification that not every vendor chose to implement. So if you have a storage array where you can set the UDID, you can use it with VMS. But if you have a storage array that doesn't offer that functionality, VMS cannot use it because it cannot figure out what device name to assign to those LUNs. Now, with iSCSI, UDIDs are implemented almost nowhere. I've looked at several iSCSI storage servers. None of the ones I examined offered the option of setting a UDID on a LUN. So what are we going to do? We've come up with what we think is a very simple solution that parallels what we did with Fiber Channel, but in a way that is universally supportable. What we're going to do is we require that the target name, the part after the colon of the IQN, end in a number. Before that number, you can have whatever you want, but the last part of it has to be a number. And that number becomes the unit part number we add the LUN number to it because you can have multiple LUNs within a target. But for simplicity, that number you put at the end of your target name becomes the unit number on VMS. So if you have an IQN that ends in :disk 100, it becomes $1 $DZA 100. So how do you mount or connect to and then mount an iSCSI disk? There's a command iSCSI CTL, which is available on operating systems like Linux and FreeBSD, OpenBSD, and it works pretty much the same everywhere. And since iSCSI is new to VMS, we figured the obvious thing to do is on OpenVMS not to be too different and just implement the same iSCSI CTL command line. So it's not a DCL command line, it's a Unix-like command line, so we'll set it up as a forward command. But you should be able to do an iSCSI CTL -A -P and then the address of your storage server, -T for target, and then the IQN for your target. So here we're connecting to that disk 100 on this iSCSI storage array, show device DZ, and now you see a device $1 $DZA 100. You can mount it, and now you have your storage.
And does he allow the name of the volume at entry a table, some system referee subtable that maps into a volume? The reason I'm saying this is it's a iSCSI, particularly in private channel, we have a problem. You can Microsoft IDs not being widely totally implemented. SCSI problem is related, but in many organizations, the organization is dropped. The storage in the organization drives name.
Right.
So it's nice, good that we say it has to end in a number, except that the over certain policies that it's now. If we just do the simple expedient of creating a LNM dollar SCSI devices, and say the volume name equals 100 equals 107, whatever, we can define that in some vehicle earlier than sorry.
The big issue we get to with that is with booting. This we'll certainly take this into consideration, but for now we think that this is the most elegant solution. And this is only a 20-minute session, so I'm sorry if I have to rush things a little bit sometimes, but because I want to get into multipathing, because that is something that people would be interested with. So what I have here is I have a fancy iSCSI storage controller. Let's call it an MSA 2060 up here. And it's got two controllers, each with two IP addresses, two network cards in two different subnets. So my 10.0.0.x network is like your fiber channel fabric A. And then my 20 network is like my fiber channel fabric B. Each of these controllers is connected to each of those networks, and then each of my two nodes in the cluster is connected to each of those two networks. So, oops, that happened to Claire as well. So I can lose a controller, I can lose a network switch, and I can lose a node, and I still have connectivity to my storage. For simplicity, I've only got one target on this disk array, only serving a single LUN. And does it look like a typical dual fabric fiber channel topology? I think it does. I think Keith has seen a diagram like this hundreds of times. Now to connect, I use that same iSCSI CTL command, but now I use it once for each of the 4 IP addresses available on that storage controller. And because of this disk100, VMS will pretty much automatically realize that this is the same device because they all become $1 $DZA100. Your multipath execlet kicks in and it will do multipathing. And if you do this on both nodes and then you show a device DZ/full, part of the output will look like this: 5 IO paths to the device, 2 through EWA0 to the 10 addresses, 2 through EWB0 to the 20 addresses, and 1 through MSCP. Obviously, this is a mock-up because we don't have working code for this yet, but this is what we currently envision that to look like. And then finally, I want to get into iSCSI booting. KVM UEFI supports booting from iSCSI out of the box. iSCSI, as far as we can tell, does not. If you boot from iSCSI in KVM, in a virtual machine that is, you get an ACPI table called IBFT, iSCSI boot feature table, firmware table. And that creates all the details on how to connect to your storage. So you set up in your UEFI BIOS the IP address, the port number, the IQN, the LUN number that you want to boot from. And if the device needs a username and password for CHAP authentication, you define that. All that information gets put into this table. And then you get to our boot manager and it will simply read that information from the table, and your $1 DZA device is now visible in the boot manager, ready to boot from it. Now, on iSCSI, if this table is not populated, we will add some command to the boot manager to define an iSCSI target from the boot manager. And what the boot manager will do underneath, it will create this ACPI table and populate it with the same information. The result will again be that you can now see $1 DZA0 in the boot manager. You boot from it. When you boot, sysboot will also look to the ACPI table, get the parameters, and then this is the part that we're going to struggle a bit with because we need to load required parts of TCP/IP before we can mount the system disk. I'm pretty sure we can get this done, but it will take some work. Then once we're booted, every LUN available on that boot target, not just the LUN we booted for, but any LUN presented by that one target will be available, but it will only be available through the one path that we used for the actual boot. So you can have those, you still need to have those 4 commands in your startup file somewhere to discover the additional parts to this target. If you want to add more targets, you can also do that in the same way, but we will probably not have booting ready in version 9.2-4. That will probably be added at a later version because things like starting TCP/IP much earlier in the boot than we currently do, and doing more also in fiber or in TCP/IP than we do for clusters over IP is going to take us some time to sort out. This is what I wanted to tell you, and if you have any questions, let me know.